Bom dia a todos. Vamos agora mudar para inglês. Good morning, everyone. Today is the last day of the 19th edition of the Brazilian Symposium on Software Quality, the SBQS. This year's SBQS edition has been organized by the Federal University of Maranhão on behalf of Professor De Viviana, who I would like to thank for his incredibly awesome effort to make things happen seamlessly. I hope you all have been enjoying this symposium, which is the most important event in Brazil to discuss both theoretical and practical aspects of software quality. During the last few days, we have watched amazing presentations from people who do research on software quality from almost every state in Brazil, from almost every region and state in Brazil. It's very nice to see that the Brazilian community on software quality is clearly growing in both size and quality as well. Today, the SBQS is dedicated to discuss more practical aspects of software quality, in a sense that we have the opportunity to understand a bit more about the boundaries between academia and industry. In this context, it's a pleasure to receive here Orges Cico from NTNU, Norway, to give his invited talk, Industry Trends in Software Engineering Education, Challenge, Future Directions, and a Roadmap. Orges holds a bachelor's and a master's in computer engineering from Politecnico di Torino in Italy. He also holds a PhD in cloud computing for business from University of Tirana in Albania, and he's currently doing his second PhD at NTNU in Norway. Previously, he was a full-time lecturer at the Canadian Institute of Technology and the Metropolitan Incubator Center Director in Tirana, Albania. Orges has participated as the country expert in several technology transfer workshops organized by the European Union Joint Research Center. In the last 8 years, he has had extensive experience in both industry and academic settings. He has participated in several project developments dedicated to cloud, mobile, and IoT systems, and taught subjects related to advanced software engineering and cloud computing and operating systems design. His current research topic is in empirical software engineering, more precisely in lean software startups and software engineering education. He has published many papers and articles in high-quality international conferences and journals such as ICSI, EASY, EDUCON, ICSOB, Frontiers in Engineering, and JSS, the Journal of Systems and Software. He has just received the Best Paper Award at ICSOB 2020, the 11th International Conference on Software Business. Orges, many thanks for having accepted my invitation. I hope we will learn much from you in this talk. Now it's your turn.
Thank you, Ivan. And by the way, in the best paper, it's also you there as co-author. So it's a collaboration paper, I think.
Yeah.
But thank you so much for inviting me in first place. I'm so happy to be in this symposium. And for me, it's the first time actually to make a presentation in Brazil, even though it's online. It's a real pleasure to encounter such lovely people again in my life. And of course, you mentioned some introduction for me, but I'm going to do a little bit of introduction for myself as well. I hope that's okay. So the topic for today is industry trends in software engineering education. And we'll look both trends in industry actually and trends in education in parallel. And I've drawn up through some challenges that are currently faced and future directions that I perceive from my current research, and then a roadmap. But before I move into that, as you said, my bachelor's and master's were from the Politecnico di Torino in Italy. And yeah, I spent part of my life in Italy doing, studying in computer engineering. And my professor was Maurizio Morisio at that time, with whom I developed the models and techniques to evaluate system and software reliability thesis. This was not a cloud computing thesis whatsoever, but it was very close to software reliability engineering. And it turned out that it would be a very interesting field for me to embark later on into a PhD which is more an industrial PhD, because it was focused more on industry context than on academic research. So what happened here was that I was doing a research on development of and testing of cloud applications for business. And I actually graduated last year on this PhD in March 2019. But it was a very good adventure because I had the possibility to actually work on real case studies and to also bring a real research context to some challenges that could be faced in cloud computing for business. But this is not the topic I'm going to discuss today, because I've been shifting from my previous PhD now, and I'm doing something similar, but sort of also in the context of my background. In 2012 and 2018, I started a company called Dominosoft, which was residing in both Albania and Norway. And this was a startup where we had a very good scaled development team where we could do outsourcing of software development. And I was presently the CEO of this company. So I spent a lot of time doing a lot of projects for different types of projects, actually, for in the industry in Norway and also in Albania. And we have also started a training program through this company where we started helping developers how to conduct or how to gain more skills. And this is where I started being even more interested in what is going on in academic context. So in 2016, I started this incubation center at another university in Tirana. It was called Metropolitan Incubator. And I was actually also directing this incubator for a couple of years. And what we did here was mainly startups. And this is how I shifted a little bit today with looking at research on lean startup context that I will start discussing a little bit later on. And the activities here was mainly to create startups with young entrepreneurs and to have the connection between industry and academia brought through the startup context. In many cases, we see these incubators as pure entrepreneurial incubators, but this was a bit particular. We wanted companies to work with the students at that particular university to create startups. And it's sort of common also in other places. And maybe my publication track has not been extending in the previous years, but I've been working very hard in the past 2 years on this topic that I mentioned. I've been publishing also in the context of IoT and cloud computing, but my main publications now are in empirical software engineering, like Ivan mentioned, and it's mainly bringing up context to startup, lean startup development within the education, software engineering education. So most of the publication in the last 2 years have been in this area of research. And what I would like to present today are a bit of my recent research results and actually the trends that I foresee, at least in software engineering, in industry and in academic context. So all the participants that are here, I would like them to be a bit active. The presentation is not going to be like a lecture for my side only, but I would like everybody to participate a little bit. And as Ivan says, maybe you learn something from me, but I also maybe learn something from you guys. I feel the symposium, it's full of very good researchers and scholars that can give their own opinions. So I would invite you, if it's possible, to go to this menti.com. It's a Mentimeter, and to use the code 2704790. So if you connect, I will share meanwhile the screen on the Mentimeter. And I will open up the presentation for you guys. Actually, the other one. Ivan, can you still see my screen?
Yes.
Yeah. So here you can read like menti.com. You can use your phone or your laptops. It doesn't matter. But it says, the first question is, what software engineering trends do you know about in industry? And there are 3 slots there to fill. So is everybody able to connect?
Yes. Ah,
DevOps.
security startups.
Yeah. Evolution. Yeah, evolution, why not? Smell. AI. Let's see who wins. The reason I did this was to sort of have people wake up a little bit in the morning. It's afternoon almost here in Trondheim. Technical debt management. Okay, AI, it's winning, obviously. IoT. So you have written also soft skills. That's interesting. That's a software engineering trend. And of course, security. And we have ML and AI. So some people think it's cloud. AI again. DevOps, yeah. I'm trying to look for some keywords that I feel are relevant for myself as well, but I think this is good because these are perceptions that we have as researchers. Yeah. Human factors. Okay, if there are no more opinions, or maybe I should wait for a couple of seconds. Okay, so we can try to go to the next one. So let me start the countdown. This is another question that might be interesting. All correct answers give max points, but here is actually, yeah, you can think about it. Which of these trends is the most explored in education? You wrote some things in industry, but which of these 5 trends here do you think are most explored? So I gave it 60 seconds just to sort of have people think, but it's sort of a no-brainer. So it's getting close to the countdown. Yeah, 3, 2, 1. Time is up. Yeah, agile software development. Actually, that's what I have found out as well. So it's not going very far from my research. We can actually come back to this slide later on and see what the research tells us. Because we see that agile, of course, is in the top, but we see software implementation, usability, and value. We don't see lean startup. That's interesting. Global software engineering, it's not, is there, and system of systems is also there. So that's good. So which one would you like to work with? Any preferences? Okay, software implementation, usability, and value. Lean software startup. Agile. Yeah, maybe agile is not getting so much popularity now. Yeah. Global. Let's see who wins. Yeah, we are having sort of a draw with big competition with software implementation, usability, and value, and lean startup. But actually in the previous one, there was little people saying that lean software startup is part of the trends. So this is interesting. Some people are interested in working with that. And yeah, some think that that trend hasn't entered the education. So that might be the case. Yeah. So perhaps I can move forward. It's only 5 slides, so it's. So question 2 of 2. It's not true, we are not giving so many points, but so what software engineering trends do you predict will emerge in the future? Just type in, what do you think will be other than those that you wrote before? I gave it a bit more time to. Let's see what we expect in 2020, 2030, and so on. And this can be software engineering trends in academic context or in industry context. I am impatiently looking at the countdown. I'm not filling in anything myself, so. So when we think about these trends, most probably we think, we might be thinking also software and biology or something else that is not, it's a wild card for software engineering, all the other streams that we haven't explored before. So we still see AI, machine learning. Of course, there is no correct answer, but ethics in software engineering, yeah, that's true. Product quality for IoT, security. This is sort of a question for myself and maybe for the Brazilian community. Blockchain, is that something that software engineering is exploring now? Is there any ideas that we might have in blockchain? But all these fields that you mentioned here, I think these are for the future. Actually, I should have written the question a bit more stringent, saying that don't mention the ones that were mentioned before, but I think it's okay. All this real continuous integration and delivery, yeah, all these are very good. I'm not sure what it means real here, but maybe it's, I wouldn't say real time, but something that really works in real context. Then we have security, privacy by design, and so on. I think all these answers are good and would be useful in the long run. So of course, there is no correct answer here. But let me switch back to my presentation. So when I looked at this software engineering trends in industry, what I tried to do was, first of all, we needed to do a correct analysis. And we started looking at the systematic mapping level, how the trends have evolved in industry and how the trends are currently being approached in research context and also in education context. Because these two options are quite critical. And there is also a gap between industry context and academic context in the long run. So of course we know something about it. And of course you mentioned a good list from before, but there is always a need for actual research and for actually stating what is the outcome of the trends of today. So this research paper was recently published in July, and it's called Exploring the Intersection Between Software Industry and Software Engineering Education. And it's actually a systematic mapping of software engineering trends. And the idea here was, of course, you find some keywords like the ones that you might have mentioned already, but what we are focusing is mainly software engineering education research and how this software engineering research, education research has addressed the different trends that come from industry. But then the question raises, what are the trends in industry? And of course, you have mentioned some of those. Before I enter that, I would just say, what were the motivations for doing this research? First, we have been having software engineering education research and software engineering in the past decades. 5 decades. So basically, we don't have a very, the field is very young and we don't have a very mature, extensive knowledge of the field. But still, we have done a lot of work. So this is one of the fields that has grown the most. And of course, by growing, it has brought an impact to the computing curricula. And not just 2020, it is beyond 2020. This is what we are worried about. And how do we address the whole challenges we have? First, we have to look at the industrial demands. That's one option. Of course, the demand cannot come also from the academic context, because the education is always, maybe it's always trying to please the industry, but it might also be vice versa. We don't know that yet. And of course, it's an open question for software engineering education in order to meet the demand, like I said, but also to drive the necessities for reviewing the current and present state of software engineering education in a general perspective. So we need to do all this within the context of 2020 and beyond that, because we don't want students to learn things like students have been learning 50 years ago, and things need to be changed and need to be addressed. So when we look at the trends, we had several authors that we could investigate, and one of those was Beam. In ICSI 2006, Beam was presenting a paper which is based on software engineering trends in industry. And this kind of sparkled a debate afterwards. The paper is very well cited. It has reached almost 1,000 citations since then. But before that, the concern was raised also by Shaw. Shaw presented a paper where it states how the software engineering education would look like. And what I tried to do was to match these two first authors, Beam and Shaw, and see, okay, one is telling something and the other one is telling a similar thing, but they are talking about two different contexts. So how can we actually address those two contexts together? And when I explored Beam and Shaw, of course, other authors popped up after 2006 and so on. And all these other authors were talking about similar, like you did also in two of the slides, we're talking about similar perspectives of software engineering trends. And for instance, reusability, COTS, open source software, very popular until the 90s. Then we have usability, user experience, human-computer interaction from the 90s and until today. And in 2000, there was a hype on Agile that we already know about that hype. And this hype on Agile, what brought was the fact that we didn't know if Agile was going to succeed, but it brought that it grew very fast. And you are aware of this. Then we have dependability engineering, which kind of, it is still there, but in safety critical systems. Then in 2005, we explored enterprise Agile, large scale Agile, and so on. So we are moving towards globalization now. And in 2010, there is a lot of research, but we are not very far away from 2010 now. It's 2020 still, and a lot of issues and challenges are still there in industry context and in education context as well. Then we have Lean Startup. Lean Startup, it's interesting because Lean Startup, people think that it's a trend, or maybe it's not a trend, but people want to work on this topic now. And then we'll see how it pops up with respect to other trends through the systematic mapping study. Then, of course, continuous software engineering that you endow with the Agile context. And then we have systems of systems, DevOps, and then computational plenty software that nobody is going to discuss this yet, because we say computational plenty, we say software engineering for autonomous systems. I didn't see this pop up a lot, but you talked about security, safety. So they enter those fields. And then we have biology and computing. So all these trends, some of those are wildcards. We don't know if there will be other trends, and we need to look into those. But all these authors were telling us until today that some of these trends are actually emerging. And to be honest, this Beam, when you look at Beam, he predicted some things in 2006. And we see again in the last rows, it's 2020, 2012, 2010, we again see Beam predictions. So this is very good because we have some idea how to predict a little bit the future with research context. And of course, we need to do more ourselves because some of the authors haven't predicted beyond the dates that we look at now. So let me move forward. How about software engineering trends in education? What do we do there? This is very important. How I conducted this study. First, what happened here was that I wanted to look at the intersection. Industry trends, software engineering education trends. And what's the common part of that? In order to do so, we need this systematic mapping study that looks at 5 important things. And these were translated into research questions afterwards. First is the identification of software industry and education common trends. And I did that. You saw those 5 trends that you voted about. Those are coming from the systematic mapping study. And then we have the identification of software engineering teaching practices. How do we teach? That's a problem. Do we know how to teach these trends afterwards? Some would say project-based learning, and that was the most common one. But of course, there are other options to teach well the different trends that we are facing in software engineering in long run. Then we have identification of software engineering models, processes, and methods, and evaluation of who are the stakeholders involved. That's very critical. Many stakeholders before were not coming from industry, but maybe were coming from just academic context, but now it's changing, and it has been changing for a long time. Sorry. And then we have the identification of research gaps. So when we look at research gaps, we see that the trends that are least explored are the ones that need more exploration, most probably. And those are the ones that you might have mentioned also before. We see a lot of Agile research. If you do a search on Agile from Google Scholar, you'd see popping up almost 600,000 maybe, or around that, papers or research items. So it's a lot. So what is happening with the other ones? And this is what I looked into. We of course analyzed a lot of sources here, and I'll tell you how much, and then conducted even more. I see Auri is drawing something on this, but maybe I'm wrong. Then we have education trends. When it comes to education trends, these are not trends that are coming just from education, but are actually trends that are being converted from the let's say, from the industry context to the education context. So what we did here was to analyze 2,000 sources, 126 papers came out of the mapping study, and then we found out, okay, Agile is the first trend. Then the second trend was software implementation, usability, and value, which you voted a lot, actually. And then we see lean software startup studies. And these lean startup studies are actually popping up in the recent decade. We see that it's actually to the equal amount to the global software engineering trend. And this is very interesting because global software engineering is quite known and it's quite explored, but software startup community is also very rapidly growing in the past 5 years. So if we look carefully at this graph here, we would observe that lean startup, we see it popping up from 2006 to 2018. And we actually see a lot of research in this context appearing in the last 3-5 years. This study was published, was submitted in 2019, just to clarify. So some data might be a bit old, but not that old. So then the least explored trend is somehow, and remember this is education context, it's from the system of systems. So what is happening here is that maybe we are facing some difficulties in the system of systems in order to address that in the education context properly. It might be a very interesting trend in industry, but education needs to address that in a proper way. So these are some of the findings, but that's not all of it. When we look at the map on how education trends have mapped to the research and contribution types, we see, first of all, we have a lot of surveys, for instance, and some framework proposals. But from the research context, there is validation and evaluation research. And that is the most explored because most probably people were trying to evaluate the field and trying to do case studies and trying to validate something furthermore within the context of education and connecting it to the industry trend, to the respective industry trend. And most studies obviously were from the Agile software development. So what was happening here that we have done a lot of effort in evaluating and validating the field, but in most of the fields here of the trends, but there is still a gap on proposing some solutions, for instance, or of course, philosophical and opinion papers are the least ones that are interesting in these fields, but we need more experienced papers, for instance, as well. So these kind of papers might be very interesting to conduct research upon, because writing a new paper on validation context, yeah, that might be interesting, but a lot of other authors have covered that field already. So maybe evaluating in real life context, that would be more interesting. providing experience papers, from how you are educating your present students, and so on. Then when we look at requirement and solution proposals, like I said, these are very critical to be addressed as well. Then do we need tools? Yeah, most probably. We need tools, we need guidelines. This is the most critical aspect of these trends here. A lot of research goes into surveys. I do surveys myself today. That's the most extensive part that I've been doing in this second research field that I'm conducting. However, it's a pity that you can write a little bit about tools and develop a little bit about tools in empirical software engineering. So when it comes to these trends, when working with students, which I actively do in 2 courses now, and I've been doing in 2-3 courses before, you need tools. And those tools that we adopt are mainly from industry. How about tools that are emerging from academic context? Those are very few. I'm not saying that there are no tools, but those tools are very meager. So we need to make more effort in providing tools for the students and providing them with the right means for them to develop something relevant. And then we have guidelines. Guidelines is the same. Guidelines papers pop up from time to time, and we observe that we have some recommendations. But of course, we need more of those recommendations, especially in the fields, in the software engineering fields that have not been explored yet. And I'm happy that we see a lot of frameworks, at least, that can help at least connect the academic context with the industry context. And this is an opinion you can bring up afterwards. We can, again, discuss it, how this should be. So when it comes to challenges, what's happening with the challenges? We are facing a lot of challenges in different areas. Here, first of all, we can discuss Agile, but in Agile software development, there are many difficulties when it comes to adopting proper Agile practices. I read something like real continuous integration or something. So yeah, I would say that there are difficulties there. For instance, designing a course in a manageable way. That is very difficult because the Agile context in industry might change a lot from the Agile context in the education setting. And then when it comes to introducing the adequate external pressure, how do we do that? Because we don't pay the students. We provide them with relevant options. In many times, one of the courses I teach at NTNU or I'm part of, is the customer-driven course. Of course, customers come from outside. They try to develop projects in Agile context with the students. They are industry customers. They are real customers. But at the end of the day, the product is a product that is never going to be sold. And that's a problem because we need to provide a real pressure for the students. They should feel that this is a really relevant project that they are developing. Then recreating Agile industry practices, it's also difficult per se, because we know that there are many practices there like Scrum, Kanban, and so on, or extreme programming. So all these practices, recreating them in another context that have originally been created from, like Agile was created in industry context in 2000. So since then we have the Scrum guide and so on, but recreating it is not that trivial. It needs some effort. It needs to understand roles. I see students of mine inventing roles out of the Scrum guide. And why? I mean, have they understood the reasons why the Scrum guide was written? And what were the authors of the Scrum guide telling us? And of course, we need to prepare students with real challenges. This is my motto, actually. This is my perception. I've been working in industry, I've been working in academia. And there is a big difference. When we want to provide them with real challenges, you have to work hard, you have to make the product work, you have to deliver it, you have to maintain it, and so on. But when you go to the academic context, some of these steps are skipped. Some of the software engineering processes are skipped, or those processes are not satisfied with the quality they deserve. So yeah, we need to prepare students to understand these aspects. And yeah, I tell some solutions. These are discussions here, but you might have other opinions, which I'd love to hear. Like integrated course modules, that could be an option. Software engineering classes and summer jobs, for instance, integrated within one course settings. Another solution could be like longer course duration. Many courses finish in 15 weeks, and then students disappear. They take another course, which is at times it's not really strongly connected to the previous one. So maybe the courses should be longer. We should span them over 2 semesters. We should connect the modules so that we get the most out of it. For instance, in the first course, the students developed with a team a certain software solution. In the second course, they can maintain it. And this can become a real product. So it's very important to connect these dots. And then active involvement of industry stakeholders. This is something that it should be done. Everybody has its own approach. We have studio-based learning. We have customer-driven, like I mentioned. Every one of these roles, like mentors, clients, customers, they pop up in a lot of papers. And at times, it's the university professors or teachers that take up these roles, like doing the mentorship or doing the pretending you are a customer and so on. But there are many drawbacks there. You know that. There are issues that come from the fact that nothing is complying to a real life scenario. So what we do today and what has been done for some time now, we have had these customer-driven courses, but we might have also other solutions like studio approach to software engineering. We might have lean startup approach to software engineering, or adapt to the new trends, like also introduce new global software engineering context and tell students to address those challenges in a different scenario. And I have my own proposals how to do this. So it's actually, you have to bring new activities outside of the course setting. What kind of activities you'd say? Okay, it might be hackathons, it might be boot camps, it might be something similar, but it's important that you bring activities to the course, like you have in real life context for real life solutions. When it comes to software implementation, usability, and value, again, here, what is being done is emulation of industry software development environment. Emulation is good, but it stops being real when you have to put it in a real life context. It's always a challenge. So it's what is the main challenge here is that you are trying to emulate the experience of the students so that they feel that they are developing a relevant product, but in some cases, those products are not really being used after the course is finished. So this is kind of a problem. And again, I would say integrate practical knowledge with theory. And this is done mainly through open labs. You can have a Fab lab, for instance, like I said, or studio-based learning, which is very known software engineering approach today. And it's actively evolving. And of course, you can have all these other stakeholders, like I mentioned before, enter the Fab lab, enter the studio-based learning, enter those environments that are very multidisciplinary, and help students with a real context instead of emulating the situations or the courses. When it comes to lean startup, and this is controversial, I find this controversy also where I'm presently working. Some people understand it, how to enter the education with lean startups, some others don't. And there is some issues here because this field is coming mainly from the entrepreneurship field. But then it transformed in 2011, it transformed through Eric, it transformed through a software engineering field, potential software engineering field. So what we are doing here is that we have challenges with mindset of students. I'm testing that. It's part of my research and I see some issues there. I'll tell you how and when. Then we look at the adoption of innovative technologies and tools. Again, here we have problems because this is relatively new. It's last 5 years that we are trying to teach this software startup to students. So that's a bit of a problematic situation. We need to tell them these are the right tools. Otherwise, we use tools randomly from project management fields or from entrepreneurship field, but we never have those tools tailored to the software engineering field. And then I say, okay, includes external activities. I really like this, doing hackathons, boot camps, software workshops. These are the ones that would bring students more context. And when I ask students through surveying or whatever, interviews, they are very happy to conduct or be part of such activities. And some of the outcomes were very positive. So active involvement of industry stakeholders, again, you need those stakeholders. You cannot do without them. That's very important in order to get the realistic context of the lean software startup, like for Agile or software implementation, usability and value, or even global software engineering and so on. So again, similar here, when we adopt global software engineering, we have issues with adopting collaborative development. We have time differences, we have cultural differences. I am doing a talk now in Brazil. It's different time, it's different context for you and for me. And imagine if we had to do a software project. I've once done a software project with a Brazilian team. It was hard for my team residing in Europe with the team, contributing with the team in Brazil due to the time differences. So that's a bit problematic. And then we have to tackle those cultural differences that we might want to express. And we have to do that online. That's even more critical. We are not sitting in the same table. And then when we look at solutions, of course, we need frameworks. Frameworks that adjust some of the issues, like how to address soft skills. And it's very nice that you mentioned soft skills at the very beginning. Soft skills are actually very critical in software engineering today. And it's a growing area that we need not overlook. Then when it comes to active involvement, it's again the same, but again, here it's a bit more tricky. How do we involve stakeholders from industry to work in two different countries and to collaborate well and to do it also with students? So these are very tricky questions because we can't expect that everybody fulfills his commitment equally and many other issues that we might face in doing so. So it's an imminent need. Beckham also mentioned this, that we need to address software engineering, global software engineering today, and we need to do it fast as well in order to achieve good results. And finally, the system of systems. It's the sort of the last trends I have identified, but here of course, we have the coordination and technical setup. That is the most challenging part of this trend. In many cases, of course, we have cloud systems, we can set it up for students, but experimenting with the real core of the cloud system, that's not easy. We need Kubernetes, we need students setting up the actual cloud by themselves, learning a little bit more, and so on. So it's a lot of hassle to do this, and some universities have the resources, some don't. But what's important here that we need to help, at least help the university context with partnering up with the industry context. And this is actually done today in most cases, even though it's very superficial, if you ask me, because giving a subscription to the Azure cloud or to the Amazon, AWS, or partnering up with the students, with the universities with some licenses, it's not enough. So there should be more into it, and the approach here should be a bit more critical than just being superficial and addressing, providing just some resources. So let me go through some directions I foresee, at least in the future, for some of these trends. First of all, like I said, Agile is the most investigated one, and we have seen that the Agile has an entire framework, lightweight frameworks such as Scrum, Kanban. You might have XP, test-driven development, or whatever, you name it. But what's important here that how are we going to address Agile in the future? First, in many cases, research cases and research papers popping up recently, we see the combination of Agile practices between each other. Like we hear Scrumban, we hear XP and Scrum, we hear Kanban and XP. So we try to mix and match those practices. It's very important because also when students do courses, they don't fully understand some of the practices to the details. But what's important is that they try to address those practices and to combine those practices. And this is also common with the industry context. And then we have to foster rapid adaptive response to change. What does this mean? Most probably all courses look the same with 10% difference from year to year. And what we want students is to learn and to adapt. We want them to understand that the industry is not a rigid scenario, but it's a scenario that is changing very rapidly. And you'd like them to work rapidly as the industry does. So we need to foster that mindset. Otherwise, we develop projects that don't expect to be changed at the end of the day, that students that feel very frustrated because the customer comes and says, oh, we need to change everything now, and so on and so forth. No, this shouldn't be the scenario. We should teach them well how to do this. And then involve external industry stakeholders. I think this is a key point. University before resided 100 years ago, maybe resided alone, didn't talk too much with industry. But now university is in the center of the urbanized cities and towns. It tries to work a lot. And I think this is similar context also in Brazil and many countries where university is closely, tightly connected with industry stakeholders. It's a pity that when I say this, because of course, 75% of the papers that I read from the systematic mapping study, they were having both education and industry stakeholders. However, still 25 it's missing. So what is wrong? We need to say that this should be maybe not 100%, but it should be 90% of the cases that university courses are collaborating with the industry stakeholders. And we need to focus on team soft skills. One of the courses I teach is, I'll present it a bit in a moment, it's about soft skills. So how come I'm introducing software engineering to that? Why is it relevant? Yes, because we need engineers to work with different disciplines today. Engineers are not sitting in their office and not talking to the project manager, or they are not talking to the marketing guy. So they are doing everything. They are talking to everybody. So we need to tell them or teach them how to talk to other entities that don't understand the engineering language, because engineering language is very methodological, while the other languages might be a little bit more open to terminology and so on. So when it comes to implementation, software implementation, usability, and value, again, we have here, I don't want to linger so much, but we have potentials here, because this is like the second trend that I have identified. You have to emphasize the software relevance to the students. You have to benefit from operation within the course, cooperation, and so on. You have to, be driven by value and reflect that value within the course and request the external industry actors to do so. Otherwise, if the stakeholders come with toy projects, then it's a problem for the students. Then we should also work in conjunctions with departments within the university. In many cases, this is not happening, but fortunately enough, here at NTNU, we have a course called Experts in Teamwork. It's mainly bringing students from every faculty to work in the same course. And that's very good because we get multidisciplinary, interdisciplinary context within the course, and we have very good outcomes with the students learning soft skills and also doing very relevant projects if we introduce some external stakeholders to the project. And lean software startup. Here I try to introduce some of those activities I mentioned, like the bootcamp activity. So we have to emphasize the realistic context. How to do that? We need to combine the teams. We need to make those multidisciplinary teams pop up in the education setting. And we need to promote the startup formation, because in many cases, I also hear this from the research community. Oh, but Orges, we don't tell students how to create a startup. We just listen to them. No, you should ask students to create startups. That might be a perspective for them to learn also software engineering. It is a real life perspective because it makes them work with the real life challenges. And then we have some incentives that we need to bring to the students. Otherwise, the students are going to regret the fact that they are taking a course that is talking about startups. What could be those incentives? They can come from industry, they can come from education, but those incentives could be also funding, for instance. In many cases, startups don't survive because they don't get funding. Then how come you ask students to create a startup without having the opportunity to get a funding option in the future? So, of course, I tried to do this with my students last year to apply for funding after they have created their minimum viable product. And it turned out to be a real life experience for them. Then we have to introduce external activities. I think this is the most outstanding option that students have. In many cases, we do boot camps in industry, we do hackathons when we see challenges, we do innovation workshops, and we also do training actually. But it's very important to tell students, you can work hard the first 3 days, and you can work hard with external stakeholders, understand the problem rather than being given the problem. This is a major difference with a customer-driven course. In a customer-driven course, the customer tells you what to do, and you are a consultant. But in a bootcamp, you can think openly about a challenge, and you can come up with a solution. And you can talk to the customer, and this is, again, a very realistic setting, what is happening today in companies. Then global software engineering. Again, here is another emerging trend. How do we solve the trend challenges? Of course, we can look at Agile through Scrum methodology. That is one option that is being adopted recently because Scrum can scale very fast, and we know this. You can have Scrum of teams, you can have Scrum of Scrums, and so on. So you can scale it, but still there are issues. I hope you guys have the time to discuss this afterwards to say, okay, what are the other practices? Because we know Agile and Scrum, it's working, but maybe it's not the only option that we should look into for the future. And systems of systems, again, we should set the expectations. It's important to understand how much students can learn. like enable deeper interaction between students and the industry, handle the uncertainty. In many cases, there are issues with cloud systems that students want to hear from the industry context how to solve those issues and maybe tackle those issues themselves. And then, of course, focusing on the technical skills. Here is not just about soft skills. That's why there is some issues here and challenges. So you can't have seated people that don't have a competence to work on the cloud and ask them, okay, can you develop now a cloud system? But in many cases, what is interesting, you can see the scenario of mobile backend as a service, for instance, and say, okay, we can have mobile applications developed for cloud systems or based on the cloud backend. So that is very good because students then can learn, okay, we can learn, become full stack developers, we can learn how to develop relevant systems, and we can be in the market very fast. So in order not to linger so much in that area, I want to switch a little bit on the lean software startup. So I was zooming out, now I would like to zoom in a little bit in the lean software startup context, because this is my research today. And what were the motivations again here? It's an emerging trend. I hope this was understood from the very beginning. It's an emerging trend that many people don't fully, or many researchers don't fully accept in the education context especially. So I feel it's underrepresented and we need to make some work done for that. So what are the difficulties? First, adopting innovative software engineering practices in software engineering education, it's always a challenge, especially if it's a new trend. And we need to foster this startup mindset. The startup mindset between the software engineering students is not that much agreed upon. So we need to foster that. We need to ask the students. We need to promote the startup mindset for many different reasons, because they can learn a realistic context of software engineering solutions and challenges. When it comes to inclusion of external activities, I have done bootcamp activities for the last 4 years, actually. 2 years I did those in the incubation center I was running, and then 2 years I switched to doing in an actual course running the bootcamp activities. In the incubation center was similar because still students were coming in, but it was not the same because adapting a bootcamp to the actual course, it's sort of different and faces many challenges. So how does this research go about? First, we have adopted for industry context, mainly interviews. There are a lot of questionnaires out there that they get the outcome. It's a lot of quantitative data. But I'm more into listening. I would like to listen what the industry wants to tell us. So I've conducted a lot of interviews in the past 2 years, and the outcomes have been pretty good because we can actually listen what the industry people are telling us for the future. Then in an academic context, we are running this design-based research. The design-based research here is an iterative process. So we are trying to derive some artifact, which is an actual model and framework, how to run the lean startup into the software engineering education context. And there have been a couple of iterations I would like to talk about very soon. So first things first, industry investigation. I've been talking to industry people in US and in Norway in the last 2 years. They have come with some very good perspectives. The picture there is one with me and one of the innovators in the US. But what stood out was the fact that, of course, we did these interviews, but they were having practices that we would see very similar to other software engineering companies. Now, all these startups were doing pretty much the same, and they were in growth phase, most of those startups. And it's very interesting because what is happening is that they are perceiving, or they're trying to get acquainted with the software engineering body of knowledge somehow in a random, chaotic way for a startup, but when they start growing, they are becoming more structured. So is it something we can adapt to the education context? Maybe yes, and this was the effort to try within the software startup research or industry research context. So surprisingly enough, after 1 year, we got this best paper from ICSOB 2020, and this was co-authored with me, Renata Souza, Letizia Giacchieri, Angdun Duke, and Ivan Macado. So this paper was quite an effort, to be honest. It's a paper that has few interviews, but a lot of content. and a lot of insights. And the insights are very strong because we went very deep in the interviews and we got what we wanted from the industry people to tell us. And that's why I'm saying that it's kind of a pilot study that can stand out because it brings value to what the community expects. Some other papers all those papers that I mentioned there are bringing some interesting results. And actually the ICSOP paper is the one on the right side, and the one on the left-hand side is a table from the EASE 2020. Here, there are some results about technical debt. I saw in the questionnaire some answers about technical debt perceptions. And technical debt is quite a growing field, I would say. But there was somehow a misunderstanding of the fact that we are managing technical debt, we are accepting technical debt, ignoring or avoiding it. And this is very critical because in many cases, when we talk about technical debt in the research community, a lot of researchers were saying, we are managing technical debt. And when you say accept, ignore, or avoid it, it's almost the same thing. But it appears not. It appears that the actual startup practitioners were perceiving it differently. And it was actually different also compared to other fields. And similarly, they were having patterns and anti-patterns in doing software engineering practices. So what I can say is that the findings are comparable to practices adopted in software engineering education. So which makes me think, why don't we adopt this lean startup practices within the education context? But we have to tailor some of those practices. This is very critical. And again, this is one of the bootcamp days at NTNU in the Experts in Teamwork course. Now the shift focus is on the education, academic investigation. And we here in Norway address a lot of these UN goals, United Nations goals. So whenever we ask students to address a project, start a project, they have to think about the UN goals. Otherwise, they are not really making the contribution, real contribution that we think they should make. And when you look at these student teams here, those teams are not made only by software engineering students, but it's also from other disciplines within the university. So you can see students from medical faculty, you can see students from economic faculty, from every field you can mention. But of course, we had around 50% of the students working in software engineering. And most products were like mobile, cloud applications, software engineering solutions, and so on. So yeah, it's very interesting to see the software engineering students work with other disciplines, come up with bright ideas, and also go and actually address all this, one of those or more of those 17 UN goals. There have been some publications here in Frontiers in Education and the Global Software Engineering Conference, EduCon, and so on. So yeah, and also ICSOP from the previous years. And those publications were well accepted, I would say. So some of the outcomes here, briefly stating, when we talk about technical skills, challenge, project management, and soft skills, we see first, the technical skills challenge is not a major variance. So what I'm trying to say here is that we observed the students and they were telling us, oh, we are learning, but not technically. We are learning how to do project management. We are learning soft skills, which is good. And then when we talked with students at the very beginning of the course, this is mainly quantitative data. I have the qualitative part, but not maybe here. But here it's easier to present with the quantitative ones. But what students were telling us with the beginning of the course was like course interest to create a startup, very low. End of the course, they had created the minimum viable product, it grew in interest. So this is interesting. And the intervention here was the bootcamp. So before bootcamp day 1, after bootcamp day 2, they were changing their minds. And this is very clearly very interesting for us to hear and also for the students. Then do they involve their present team members? Some say yes, some say no, there is mixed feelings there, but it's not very critical. It's actually the motivation they have that counts. And we conducted the study in 2020 again. We gathered the data from both years and boom, the same results. Students were having no technical skill, knowledge increase, but they were having mainly soft skill increase and improvements, soft skill knowledge, and also project management. So this was actually telling us sort of in a statistical way that we are in the right direction. Doing boot camps, bringing students with relevant projects and teaching them soft skills. And Are they interested in startups? Yes, this was the outcome. So I've mentioned most of the key takeaways, but when it comes to technical skills, as I said, there is nothing like that in this kind of effort that we made in this course. Maybe it's different in other courses, but what's important here is that students can make their own technical decisions. And this is very real life scenario for a professional, for a software engineering practitioner or professional. And that soft skills were improved, which was what it counted in this case, and same applied to project management skills. And as I said, startup formation mindset had a big increase. And this is very good. So moving on, what is happening is that we try to derive a model, first iteration and second iteration of our implementation of the research, design-based research. So first model looks like thin a little bit, but when we come and observe in more detail all the activities we conducted, it became a little bit more robust. The model is undergoing a new iteration this year, and we hope to derive a concrete framework and a methodology how to do this properly in the education context, how to bring startup formal education within the software engineering education context. So finally, some roadmap, what we should do. Maybe I linger too much, but let's hope we finish within the time frame I expected. So first, how do educators, researchers, and practitioners address the software engineering trends? And again, since I talked too much until now, I'd like you to join again the Mentimeter and answer just this one question. How do you feel can educators, researchers, and practitioners address the software engineering trends? And I'll try to open the browser again and move to the presentation, to the Menti presentation actually. And I would really love to hear your opinions on this question. The code is 89 40 27 9. So if you move to menti.com and use this code, it should be fine. So we see soft skills development, software studio approach, real world projects. Use computation tools, interaction. Yeah, interaction is interesting keyword because it says something interaction, but with whom? Between the student team, between the students, and interaction between researchers, between practitioners. And I feel it's going in the right direction. If we interact much more, that would be very interesting. Inviting professionals, I like it. Practical problems. Problem-based learning or project-based. Yeah. Using computation tools. Yeah, we need more of those, most probably. Yeah. So interaction with industry, and the question is more, how can educators, researchers, and practitioners address those trends? And the interaction, yeah, that's true. The question is, sometimes education is very much trying to fulfill the needs from the industry. But I am a promoter that also education can be a driver. Why should industry be the driver? We can work hard at education and make industry come to us instead of academics going to the industry and asking for things, for solutions, for whatever they feel should be done. So I really like the interaction keyword. But we need also to facilitate this interaction. That's very critical. How do we achieve the interaction? Do we have some means, some tools, some frameworks, some ideas? Okay, I'm gonna give it a few more seconds. Yeah, challenge-based learning, I see CBL. Yeah, that's very interesting. These are all keywords that I have popped up while doing the mapping study. So I feel a lot of researchers here have had their fair share of experience with this kind of research from before. Yeah. So if I move back to the presentation for a moment, and maybe you can, I'm not sure, maybe you can continue on filling in the answers. From my perspective, I feel the interaction is very important. It's very good that you mention it. We have the example of the island here that, the problem is when you don't interact, leave alone, leave separate, you don't know what is coming, and when it is coming, you don't know how to address it. So I really encourage the exploration, explore emerging software engineering trends, explore lean software startup, explore global software engineering, explore other trends that might be coming after 2020, autonomous systems or whatever, as soon as possible, even before the industry does that. I think it's very important for educators to look into potential trends themselves instead of reaching out to the industry and asking, oh, what are you doing next? No, you can talk to the industry and understand what there might need, what might there be they need in the future. So yeah, you can actually do that, and you can predict some things yourself instead of just waiting for the answers. Then provide courses that have more realistic software engineering settings. And this is something we agreed upon, everybody agreed upon, I think. And finally, foster the collaboration. I think it's very, very critical to have the means to foster this collaboration. Otherwise, if we don't do joint activities, if we don't participate, joint activities could be bootcamp, workshop days, whatever, you name it, but introduce all the time some industry context to the course, even if it's bachelor studies, it doesn't really matter. The sooner you face the challenges from industry, students will learn the most. So they'll be the ones that are very active. And this is from my experience as well. I've been working in bachelor studies, master studies, and I see students at bachelor studies that are better programmers than the ones at their master studies in many cases. And the reason is because they have very early contact with the industry. So don't wait, foster that contact earlier. Why should you wait until students go to their 4th, 5th year or whatever at their master studies? Then what you can do is evaluate the potentials of emerging and future trends. Like I said before, explore, evaluate, experiment with the courses. Don't shy out in doing so, because this will bring more explicit, let's say, innovation to the course, but also bring more knowledge to the students. So you can also explore the low-cost software development opportunities. You can tell the industries, come to us with real-life cases, and you get the software, your software, very cheap, instead of just having do outsourcing in many cases. So if your students are good, they can produce a software. They can produce a meaningful full software that can be used in the future for the customer. So why don't you market this? Motivate the students, motivate employment, you should motivate to decrease the skill gap that they have from a technical perspective, because if you motivate them to work with the industry people earlier, then most probably they will have less, they'll be less afraid from the technical skills. There is some studies that could bring up the perception that students have at the very early stage of doing software development, that they are afraid of the software development themselves. So they should stop the fear and continue to get more experience as soon as possible. And then develop new teaching methods. This is what I'm trying to do. Of course, it's a PhD, it's a research context, but the main outcome here is that you should try to develop those teaching methods that are relevant. It's very, very critical to understand the trends, but also understand how you can bring new things to those trends. It's not just about knowing Agile and adopting Agile. It's also about bringing new context to Agile from the education perspective. Then validate. Researchers can validate emerging trends such as lean software startups and global software engineering. Propose something that it's interesting, especially tools, and tools are very, very critical and very, very important on the long run. And finally, guidelines for future research direction should be always there. And finally, you should propose solutions. Researchers can propose solutions themselves. They can look into industry. They can look into the academic context. And mixed methods, mixed models, frameworks, whatever they want to do, they can propose those methods. And this can be solution proposals. They don't have to be validated, because we saw a lot of validation research from before. So the more you propose, maybe the better is also for the educators, because yeah, at many times we do teaching and we do research in parallel. So we try to educate and try to read what the others are telling us from the research perspective, more than from the industry perspective. And finally, practitioners, they can benefit from the whole picture here. They can benefit from the large amount of validation research that we have already presented in education setting, but they can also benefit from the knowledge transferable from software engineering education to the industry context. So what I'm trying to say here is that we need to look into the possibility and the potential that it's not only the industry bringing us knowledge, but also the education bringing knowledge to the industry. So it should be that cooperation that you mentioned, a bit more tightened up between the two entities. And finally, sort of to conclude, we would like to have the practitioners, like industry stakeholders, to trigger a standard software engineering education curricula. Why should they be the trigger? Because they are very passive in many cases, and we are the ones that need to invite them. But at times, the trigger should come also from the practitioners. They should work and understand the fact that education can bring a lot of value to their companies and to their future programs, like and the training programs that they have, a lot of effort that they spend when they hire a new software, junior software developer or whatever. So it's very important for the industry to invest into and trigger the change in the curricula as well. And then who provides the financial means? I mean, I had this similar presentation a couple of weeks ago at Profess, but the question was, is it political? Is it something like politics should be regulating some of the issues that we have? Maybe yes, I don't have the answer, but what's important here is that there should be some financial instruments that are dedicated to this cooperation, academic, industry cooperation, and especially if you ask me about lean software startup today. So disclose the software engineering practices earlier. A lot of things going on in industry are patented, are very, very closed, are not open to the broader market. So at times we need to work very hard in order to understand what the industry is doing next. So maybe a solution would be that education does more things than the industry or does a similar approach by itself, but education is very open. We don't want to patent a lot of things. We want to give knowledge and spread knowledge. And having a structured framework, this I foresee to be very relevant. It's very crucial that we have a framework that tells how the collaboration should be done. Otherwise, in many cases, it's chaotic, it's not structured, and we lose the whole content that we need for the student to face real life challenges that they should be facing. And the framework would supposedly increase the quality of the projects at the end of the day for all the students that are participating in software engineering courses. And finally, provide expectations of future software engineering employee skills, for instance. Every practitioner can say something about this. I've been a practitioner myself, running teams, development teams, and I know what are the expectations from a development team. And I understand those expectations, but they should be also communicated as well. So apart from providing expectation and fostering them aligned to the learning outcomes in engineering education, we should also try to articulate those expectations very well with educators and the competences we expect from everybody. So this sort of wraps up the whole presentation. I maybe took a little bit longer, but I really wanted to do those questionnaires and to get your opinions as well. So thank you very much, and I really hope you have learned something from me as I have learned some interesting facts from you, and I see that a lot of answers from your from the questions I made, and your answers were very much fitting with what I've been researching so far. So again, thank you, and thank you, Ivan, for inviting me to this symposium, which I feel is very interesting and very relevant to my research.
Thank you, Ortiz, for the awesome talk. We have got some time, I guess 10 minutes for questions. Let everybody say thanks to Orgit. Do you have any questions? If you have questions em português, let me switch to português. Se vocês tiverem alguma questão em português, vocês podem colocar aqui que eu faço a tradução. Tudo bem? Let's switch again to English. Orgit, while people is thinking of questions, I've got some questions here. The first question is, we have seen many studies teaching how to teach agile methods, for example, for both grad and undergrad courses. What do you think about any startup-driven course? Have you seen any kind of guideline or books or something like this? Startup-driven.
Yeah, personally speaking, when you say startup-driven, it fits 100% with what I'm doing. My village, I would call it village, but it's a course actually. It's startup-driven software engineering for social good. So it brings UN goals together with software engineering, but it's startup-driven. So students had to create a startup. Unfortunately, I didn't find any guidelines to be so strong that to say that, okay, this is how I should do it. But I like experimenting, and I feel that in some courses we can still experiment. Like this course, Experts in Teamwork, it's a course where a lot of faculties bring in students, and I try to hire students, not hire, but to get students from software engineering. And what I do, I tell them, okay, you work with the students that are from different study fields. You have multidisciplinary team. But then the startup is very similar to your context. In a startup, you don't only have software developers, you also have people that talk about marketing and other stuff that are relevant to the startup. So basically, yeah, I feel this course should be a very interesting point. There is a studio-based learning. Studio-based learning, it's very similar to what I'm doing. They have done design-based research before, and they have come up with very good, great results, I would say, because they have sort of a startup ecosystem. This is mainly brought in Finland, where they have the startup ecosystem, and they try to bring all the students to work in that ecosystem and to sort of develop interesting products and so on. So I feel there is no such framework that you can refer immediately, but people are making efforts, good efforts. So it would be good for us to work now on that, Ivan, and maybe other people can say, oh, something has been done before.
Yeah.
But another question here. What kind of activities are you using to develop soft skill actually useful to industry setting? Yeah, that's a good question. Yeah, thank you, Sheila. We have actually a guideline from the faculty in order that tells us how to teach this course. And a lot of exercises, I have to be honest, are taken from psychology. Now, I am not a psychology expert, but, and I don't teach the students actually how to do psychology, teamwork, team dynamics, but we provide them exercises, and we have facilitators that work with this, and they try to facilitate the students and to tell the students, this is the exercise you have today, like ice breaking or discussion, giving and receiving feedback, all these kind of things that are important for soft skills. And they sit in a round table, they do these exercises that students gain a lot. I have that book. Maybe I can point to that link afterwards, or yeah, I can share that link to the course. It's called Experts in Teamwork, NTNU. And what they do, it's actually, they provide a lot of information on how this works. Although I feel the book, it's reserved for the team leader, no, the village leaders. So if you write Experts in Teamwork, you'll see how this works, most probably. And you'll have some of the information here if you feel it's important.
Thank you very much.
And I hope, I pasted in the chat now. And I hope it answers your question.
Okay.
Thanks.
Great. On the chat, we have another question from Aito.
I would like to say thank you to Heitor first for liking the talk. And the question is, I think one of points highlighted is the participation of industry mentors to support the teaching and learning process. On the other hand, these mentors have their activities and they are very busy. Yeah, I know. Would you have any tips to approach these mentors and sensitized to help in this process? Yeah, I feel the mentorship, which is coming from academia in many cases, but it's also coming from industry, especially in this customer-driven course that I mentioned. Yeah, in that case, the mentors are industry guys. So they know they can spend 1 or 2 days a week with the students and they commit. But when they are in academic setting, sometimes it's a bit, I would say less, I wouldn't say less professional, but it's a mix because in education context, they will focus more, the mentorship might focus more on theoretical aspects. So my perception is the way we can facilitate this for the mentors is first of all to have mixed mentors from both academic and from the education sector. And then we should promote this as a teaching approach, having mentorship for every course and bringing realistic setting for every course. Then maybe we find out some tools and means in order to incentivize them, to tell them, okay, these 2 days of the week, you work only on the course and you do only mentorship. You are not going to spend administrative tasks or something else. And we call this somehow duty work here at NTNU. I have 10 hours a week where I spend only on doing, for instance, supervising or mentorship on the customer-driven course. So 10 hours, I don't have to do research, I don't have to teach, but I just have to spend with students. Maybe I distribute this in different days. It doesn't have to be 10 hours a day, but yeah, you understand the point. Even if it is 2 hours every day, I can spend only with my team and I can supervise and I can do the mentorship. So Heitor, I don't have maybe a strict answer for this, but these are some options, I would say. And I hope I answer your question.
Thank you.
Thank you.
Yeah, you're welcome.
Any more questions?
Maybe I had one point that I wanted to discuss. What do you think is the future in, for instance, what agile methodologies would you propose, for instance, or even in global software engineering? This is sort of one of the directions that we know Agile and Scrum, but are there any opinions? Just not to make it a question and answers. Maybe it's a discussion that we could bring up shortly. Are there interested people in global software engineering in the panel? I'm not sure, Ivan.
Yeah. There are many very important researchers here in Brazil that work in this direction. I guess Rafael from PUC, you know, Rafael Prikladnik is one of the most important guys here in Brazil that talk about this, but unfortunately he's not here with us.
I skipped the discussion.
No. But there are many other researchers very interested in this.
That's okay.
I have a last question. Do you think it's possible for a student to wear both hats, like a startup CEO while he is studying a graduate course?
Yeah.
What do you think about it? Or they are mutually exclusive duties?
Yeah, but good I am on the right slide. This guy here who looks much younger than me, I'm still sharing. Yeah, I'm still sharing. So he is a student at University of Michigan. So yeah, he was working and he had this startup grow quite fast, I would say. Yeah, I lost the slide. But yeah, he was a student. You can see he is a student, he's very young. And he's the CEO of the company. So in many cases, risk takers are young people. And I feel it's the same in Brazil, it's the same in US, it's the same almost in every country in the world. although the statistics tell some different things, like if you go to the XOB and you listen to Xiaofeng, for instance, she says, yeah, the average entrepreneur guy or software business guy or entrepreneur is about 30. But I would disagree a little bit. If you think about startups 20 years ago when Facebook came up, and then we had Instagram and some other companies, and also when you had Microsoft, all these were very young people. They were students in many cases. So yeah, why not? They can wear the hat of the entrepreneur. They can be very successful. I think they have proven that. I don't think that's something that we should be afraid of, experimenting with students. They can be very bright. I feel they can do things that we don't expect them to do. And I think that's the interesting case here.
Yeah, maybe the guideline for teaching a startup or a startup-driven course should include some advices on how to do both in practice. But thanks for your answer. There is a last question here. How do you see cloud outsource for microservices? I don't know. Yeah, this is the last question, okay?
No problem. I was trying to read it in Brazilian, but Portuguese, but yeah. Como ele vê, no, yeah. So microservices. In this case, I think the question is, how can you outsource the microservices? Is that correct?
Or maybe there is a concept cloud outsource. I don't know exactly.
Cloud outsource?
Cloud outsource.
Yeah. Maybe Carlos.
Bom dia. Posso explicar em português e você traduz para ele?
Por favor, por favor.
Yeah.
He's explaining Portuguese, the author of the question.
It's okay.
Eu entendo como microserviços cloud software quando você tem uma necessidade de desenvolvimento de algum microserviço e você lança isso na nuvem e alguém no mundo vai pegar isso para desenvolver e vai lhe entregar. Tá? Então, isso vejo como uma tendência, né, porque facilita, mas a gestão é complexa, mas eu vejo isso como uma tendência para microserviços. Eu quero saber qual é a percepção disso, de futuro para isso.
Okay. Okay. Or this. Let me see if I got a question. There are some microservices that are not built by the same developer, the same company, but they are third parties that develop them. You know, yeah. do you see that this stuff could be a trend, for example?
Yeah. One interesting aspect I noticed with growth phase startups was that when you have the code available, of course you can redevelop it, but it's also a matter of quality of the code. And they were trying, in US at least, they were trying, a lot of companies, they were trying to write readable code. So one of the patterns I explored, and it's actually here, was, readable code. So they didn't do documentation, is the first one, but they wrote readable code. And the reason was that when you switch from one developer to the next, you don't have the hassle of understanding what has been developed. Of course, in some cases, you should document because some implementations are more difficult than others, more complex than others. But writing the readable code was a pattern, and it was a very good pattern, I would say. And I think it fits for this microservices, which I feel it's a relevant field in the future. A lot of implementations now, especially on cloud systems and operating systems, they are based on microservices. So yeah, I'm using another background now, but yeah, I think this is very, very relevant field. And the cloud computing and integrated with AI and blockchain, and I was a bit surprised that blockchain was not so much in education as well. When I researched, I think it's quite a field, and they are running microservices in IoT as well, and so on. So I think it's quite relevant. And I thank you, Carlos, for the question. And I tried to understand a bit of Portuguese. For translation.
Yeah. Okay, Jorge. Thank you again. Let's say thank you again for your time and effort to deliver a very nice talk. I guess now we are more smart. We are smarter than at the beginning of your talk, because now we know a bit more about the trends in the software engineering education field. Thank you so much for sharing with us all your knowledge. And see you let's say
See you.
thank you.
Yeah.
Thank
Thank
you,
you so
Ariel.
much. Yes.
Thanks for the presentation.
Please open your camera.
Your cameras, yes, for
Pessoal,
a picture,
abram
for a
suas
shot.
câmeras, por favor, para a gente dar uma salva de palmas pro Orges.
Thank you so much. And thank you for the participation and very good answers. I'll try to share the answers with everybody. I feel it's very, very relevant for me to hear from other people what they think. So thank you so much. You've been
Thanks
very
so
good.
much, Orges.
Great, Jorge. See you.
See you. Bye-bye. Good luck with the conference.
Davi?